Hello and welcome to Unsupervised Thinking, a podcast on neuroscience, artificial intelligence, and science more broadly. We are a group of computational neuroscientists. I'm Grace.
I'm Josh.
And I'm Jan.
And the topic for this episode is generative models and the stuff you can do with them. So this is a class of model in machine learning and artificial intelligence. And as its name suggests, it generates things. It's a class of model that allows you to generate images, text, data, whatever you want. And so we're just going to talk about kind of what these models are like, what they do, why you would want them, how they can be used for good or evil, and how they can be used in neuroscience or how they relate to the brain even. And so for this, we read kind of a bunch of different scattered things, I guess, because it's a big topic. But one of the main things was a blog from OpenAI that where they described some generative model architectures and the work that they do with them, and then also a Wired article about some of the more nefarious uses of generative models for political and social reasons. And we will link to those two and whatever other random things we mention on the website, as always. So these models are a form of model that is trained via unsupervised learning. So if you listen to our deep learning episode from a very long time ago, we talk about the different types of learning you can do in machine learning, and unsupervised basically means that you don't have labeled data. So in supervised learning, you have like an image, and then you have like the word cat because there's a cat in that image. But in unsupervised, you could just have a bunch of images, and you don't know what's in them, or you don't have any tag associated with any of them. And these are models that can be trained using that kind of data that doesn't have any associated labels. And kind of the purpose of these generative models is to take a bunch of data and be able to generate something that looks like that data, not to generate something that was exactly in that data. Like if there's a picture of your cat in the data set, you don't want the model to just spit that back out because that's not interesting. That's just kind of memorizing the image. You want to be able to train a model with a bunch of unlabeled data and then tell the model to produce something, and if like you looked at that something, you'd be like, yeah, that looks like it came from that pile of data.
Just like for clarification, it could be just your cat, but it could be like many different pictures of your cat, or like many different perspectives or angles on that one cat. And then like a generative model would also be something that like on different days with different lighting conditions from different camera angles could generate pictures of the same cat, and that would just be like a very specific generative model. Also, like, I think it's worth keeping in mind that the whole field of generative modeling is, like, in terms of it actually working, is pretty new. Like, if you asked people 10 years ago what the state of generative modeling was for kind of any domain, like speech or images, like, it was very crude. And so, I mean, I can recall when I was an undergrad, we worked on things that were related to natural images and being able to generate things with the statistics of natural images. And the state of the art then was to generate things that like barely had coherent structure. So like this field has rapidly progressed, especially like the image generation as a sort of core example, but all of the domains of it have progressed from basically like you couldn't do this to now you can do this in a way that is like you can just build a model that can sample images from a specific subset of images like very, very well, like with almost photorealism, which is kind of shocking in terms of like the rate of progress in this field.
So this has a lot to do with kind of the deep learning revolution that happened as well. So the models that people are using to generate images are now very deep and trained on a lot of data, which is kind of the same reason that data processing and kind of classification of images has excelled recently as well. But yeah, so like the old days of natural image statistics, I remember those images being like kind of like foggy textures or something, like not very coherent objects or anything like that. And now you can see images of faces that they're usually trained on, or at least a lot of the ones that you see in like social media that's shared and stuff, they're trained on celebrity data sets. So it's like people's faces when they're on the red carpet or something like that. And so you see these generated images and they look like, is that a celebrity I know? It's like you think like, is that someone famous? Because it's taken from that data set, but it's no one in particular. It's some weird combination of a bunch of features that all existed in that data set. And we're kind of talking about this idea, like the statistics of the data, like you're drawing from the sample of celebrity like images. And so that's kind of a core concept for generative modeling. The idea is to try to capture the distribution of the data so that you can pull something new from it. So like if you had a distribution of numbers like height or something like that, you can describe the distribution of, say, like the height of men with a Gaussian distribution that has some mean and some variance. And those are two sufficient statistics to describe that distribution. So if you got a bunch of data and you estimated the mean and variance of that data, then you could pull from a distribution that has that mean and variance, and you'd be like sampling possible heights of men that comes from the same distribution as your data, but the samples that you pull wouldn't be exactly from that data. So there could be someone who is like 5'7" in the data, and you can pull someone who's like 5'7.25" or something like that from a distribution once you've fit that model. So the idea is to capture like a compressed form of the data that describes what's necessary about the data to be able to generate new samples from it that are realistic and kind of look like or feel like the true data.
I guess what struck me, I mean, I'm speaking mainly about the GAN sort of development that happened the last couple of years ago, was that struck me is that like when you look at the artificial images there, or the generated images there, they seem much more natural than the previous state of the art. There was features in the other competitors that just didn't make any sense. There'd be like suddenly you'd have like a face and then one weird feature would pop out that like really, you wouldn't expect to see that in the face, whereas that didn't seem to happen in the previous in sort of the GANs. And what's happened since then is essentially, like, to me anyway, it seems like they capture something that makes more sense somehow.
Yeah, so we could talk about the different types of models that are used to generate images, like images in particular we can talk about, because that is a big example where a lot of progress has been made and something that seems kind of impossible, and yet people are doing it to like generate images that look like photographs essentially from nothing. So you guys were talking about GANs, so that generative adversarial networks. So these are, the way that those work is kind of like you have a network that generates an image. So basically an image is obviously like a bunch of pixel values arranged, in a grid. So if you have like 10 by 10 image, then you have like 100 pixels, and that would be a very, very small image. So usually are trying to generate something, if it's supposed to look realistic, it has to be very large and high pixel density. And so basically you can have a model that to generate one of these is kind of the opposite of the models that classify them. So we talked about this again in our deep learning episode, but there's these convolutional neural networks that can process images. They can take in an image and do a bunch of layers of processing and output a classification like a cat or an airplane or something. And so if you kind of turn that upside down and put something in at the top layer that kind of represents a classification maybe, and then run it backwards, you get pixel values. You can create pixel values. And when you do that at first, that's not going to look like anything. It's going to be a bunch of random pixel values that come from the random initialization of this network. The key to GANs is that you then have a different network that takes in that randomly generated image and says, is this a real image or a fake image? So it knows what real images look like because you give it real images as part of this process of asking, is it real or fake? So some of them will be real and some of them will be generated by this model. And basically by going back and forth and having the model update its parameters based on whether it's discriminating these images well, you can refine this generator model so that it keeps trying to trick the discriminator and say like, oh, you think that this fake image that I generated is real, so like that's good. You want the generator to trick the discriminator into thinking that a fake image is real. So if you have something really obvious, like some features that don't happen in images at all, like a big block of black pixels, like that's going to be easy for the network to discriminate. And same thing for blurry images. Like if real images have a lot of variance of their pixels, like high resolution where things are actually different, if you generate a blurry image, which is a problem that a lot of old generative models have, that's going to be like a clue to the network that it's fake. So these GANs are kind of pressured to get all of the important things about real images right.
But I think like at one step higher, right? I mean, what you're doing here is you're taking, like, you sample some random noise and you transform it into an image via this network. That's basically what's going on in the generative model, and it's kind of shocking that like that can work, right? I mean, ultimately what you've done, And I mean, because it's working so well, it's like it's almost worth stepping back and sort of defamiliarizing yourself with this and thinking like, okay, so now this has been working for some number of years, and that's great, and it is very cool. But like again, like as of like 10 years ago, even the idea that you would be able to sample like 100 random numbers and convert that into a photorealistic face, like it wasn't obvious that could be done. And it wasn't obvious that would capture like something rich about the distribution of faces. Like you might think, and these are problems that you run into, that for example you would only capture a very narrow subset of the distribution of faces, or you might try to like memorize too much about like a small data set of faces, and those are issues that you run into. But it turns out that as far as we can tell, those issues like aren't so insurmountable. It seems like it is just like feasible to take 100 random numbers and transform them into something photorealistic, like either faces or something else.
Yeah.
Yeah, it is the case that memorization could be a problem because, yeah, if you spit out an image that was in the training set, it'll look real and you'll be like, wow, this GAN is doing great, if you didn't realize that was in the training set. But obviously, given that a big part of making generative models is compressing the information and trying to get to some sufficient representation of it, the fact that you have this bottleneck where you can only input, say, 100 numbers at the top layer and then those propagate back to produce the pixels, you kind of like have to be compressing something, which might make it harder to memorize anything because you lose information at some point along the network, or you're forced to compress it a lot compared to the dimensions of the image, which is however many pixels you have times 3 usually, because it's RGB color images.
Yeah, and then I think what's interesting as well then is if you take the lower dimensional representation and you just like move in a path along that way, you can see the transition from particular types of face gradually turning into a particular another type of face maybe, which it kind of shows, or it very neatly demonstrates that it's really capturing something about face or something and just compressing it basically, which is nice.
Yeah, and so in addition to just being like cool ways to generate new images, it is like generative models are used to kind of understand the structure of data as well, to find what minimal set of things you can use to describe data in a way that still captures all of the important parts. And so that's something that's been around for a while with like autoencoders. So these are models where you input an image or whatever your data is in some form, you input that to the model, and then the model it's layers of artificial neural networks, and it passes that information along, and as you go through the layers get smaller, so there's fewer artificial neural units at each layer until you kind of reach this bottleneck point, and then it branches back out again. So it's kind of like an hourglass shape, the architecture of the network. And the idea is that from the bottom to the narrowest part, you're kind of encoding the information you put in, and then the goal of the model is to replicate that exact thing. So from the middle narrow point to the top of the hourglass is kind of a network that's meant to recreate the exact image that was put into it. And so that gives you very clear means of evaluating the ability of the model, because you can just compare what you put in to what the model outputted on the other end. But then the valuable thing there is that middle narrow part of the network has learned some really low dimensional small representation of the data that you put in. If it's able to do this successfully, it means it found something that is sufficient to describe the data enough to recreate it with some high level of accuracy.
And so getting back to what Jan was saying, I mean, I think these are the kinds of architectures where you expect the middle bottleneck layer to be like sort of semantically interesting. Like if this model is trained on faces and you put in a whole bunch of faces and you're supposed to recreate them, you'll start learning units that are like, is the person wearing sunglasses? Or does the person have curly hair? Or, things about like, is the face long or stout? Or, all these different features. What color eyes does the person have? And then you can gradually, like, you could put in a person's face and you could turn the knobs on these sort of middle units and gradually deform the reconstruction of that inputted face and be able to sort of get deformations of it that like semantically vary in an interesting way. So like you can change the person's face from having curly hair to not having curly hair gradually, or transfer the sort of expression, like the smile that one person has to another person, by sort of blending certain of these features at the bottleneck. And this is kind of an interesting and cool thing that gives you sort of power, almost creative control over the reproductions.
Yeah, and so the basic architecture I described is just like the standard autoencoder, and then there's this kind of addition or modification that came later called variational autoencoders that are even more explicit about making those middle layers something that you can interpret, like making it like a continuous set of values that relate to each other in a more reasonable way, and also allow you to like literally draw from a probability distribution. The way that those middle layers are represented, you can just draw a number from a distribution and create an image based off of that. But so what's interesting is that these different models have obviously kind of different pros and cons. So GANs are pretty hard to train and don't have a lot of theory around them. You know, they're kind of, from a like mathematical perspective, they're ugly and clunky and just they're a thing that works, but they're not elegant.
Well, I mean, so while that has been true, like even from the original GAN paper, there was some like game theory about how this was being trained, and I think from a certain and more theory has been recently developed about these sort of being generative models of a certain sort that you can think of as like implicit generative models or things like this. So I do think that while they may be the training procedure for GANs may be a bit more opaque and like a bit less classical, I think there are people who think of them as a sort of well-posed generative models.
Okay, you're on record as defending GANs.
No, I don't want to be. I don't want to be on record I mean, I think it's just like there is an ongoing discussion about what makes a generative model, and people are changing the semantics of this word. Like traditionally, it meant something maybe more specific about how people in Bayesian modeling were using the word generative model, and now the term has been relaxed a bit. But it's not just a relaxation. I think people are also trying to figure out ways of reinterpreting things that are not explicitly like Bayesian models in the sort of formerly strict sense as generative models. Like how can you see them as generative models under what perspective mathematically?
But yeah, so then the cons for something like autoencoders is that because of the way that you evaluate the quality of the output by comparing it to the input itself, it seems like these things produce, in the case of images, they'll produce blurrier images because the error isn't considered that large if you kind of have a few pixels off from what they should be, whereas GANs will use that, the discriminator in GANs will use something like that to mark the image as fake rather than real. So depending on, you know, what's important to you in the thing that you're generating, you would want to use one or another of these models. Another variant that's used are autoregressive models. So these are usually, so I should say that the previous models that we were talking about are feed-forward models. They're just kind of one direction of flow from the artificial units in the networks to the next layers. But autoregressive models are recurrent models, so neurons can connect to each other in loops and kind of can progress. The activity of these units can progress over time based on how they influence each other. And so these can be used to kind of, the way to think about it is you kind of have to turn whatever data you're working with into something that has a time series component. So even if you're dealing with an image, which obviously doesn't have like, there's no temporal order to an image if you just have a single image. But if you're using these kinds of models, you would think of the pixels in an image going from, you know, like top to bottom, left to right. And so you could order the pixels in an image.
Like the way you would raster scan it.
And so then you can generate the value of a pixel based on the values of all the other pixels that came before it. So the goal of this model is to kind of learn the probability distribution of what is the probability of this pixel being green given that the 3 pixels before it were green, something like that. And you can generate images pixel by pixel through this kind of progressive way that makes it seem like it has some temporal order even when it doesn't, because there are dependencies between pixels that are near each other, and there can be longer term dependencies that these kind of models can capture.
I find that quite surprising that it can do well just from looking at pixels? I mean, do you know with like the spatial, like the typical spatial length of like the dependencies, or?
Well, so this, like, the general idea is that you're generating pixel at a time given, the pixels that you've already generated in the past. But the models themselves, that's what they output, but they can have any architecture you want. So they can be multi-layer recurrent neural networks with like convolutions that are then recurrent. Like, it can be very complex architectures that can take into account long-term dependencies for sure.
Okay. But then with the way, I guess, is there a way of like opening it up and seeing what the different what the future maps are and this kind of stuff, or is that still kind of?
You mean like, has anyone tried to interpret these models and see what they learn? I think like generally there's not a lot of people trying to interpret models that have been trained to do cool stuff, so probably there isn't much for this.
But I mean, there's a little bit. I mean, you could sometimes show these things, like you could be a little bit more specific. And so like if you take digit, so there's the simple digit data sets, like MNIST is the classic one for numbers, but there's also like Omniglot, which is a bunch of different like obscure languages. They're alphabets and things like this. And so those are characters, right? And so there's characters and digits, and they're basically small images. And you can sometimes train these things in such a way that you start getting like things that kind of look like strokes that get generated.
Sure.
Like not necessarily strokes the way a human would do it, but where like part of the digit or character gets drawn, and then another part of it gets drawn, and then another part of it gets drawn. And so it's at first glance, I think it is strange to think of creating an image in a way that's like raster scanned.
Yeah.
But if you think of it as like a fuzzy raster scan, where you're allowed to like almost draw, or like depending on the kinds of models they actually like view themselves, like people who are interpreting them or creating them will like view them as drawing something, then you're in a position where it's more like you are iteratively refining an image. Like you first put down part of an image, and then you sort of refine that image based on what's already down. And so this is just like a way of sharpening the image, is one perspective on this. So like, right, if you were, I don't know if you see, what's his name, Bob White, the guy who does all the painting?
Bob Ross?
Bob Ross, okay. Okay. You see Bob Ross, like the way he draws a painting will be like, okay, first like get a whole bunch of color down that's like for the sky and like the the horizon boundary, and then start drawing some sketches of trees, and then you add like the fine detailing later.
Yeah.
And if you wanted to draw a face, it wouldn't be the case necessarily that you would just take like a feed forward network producing a face is just going to like spit out the whole thing at once. Whereas like one procedure you could imagine might help produce refined faces is to like have a canvas and iteratively refine the face that you produce. Like first put down some color that represents like the general shape of the face, and then refine it from there. And that may or may not produce a better face, but that's like one candidate architecture.
And what this also means is that these models, while they can start from scratch and kind of put down their own blurry thing first and then refine it, you can also put in something that already exists and have the models finish it, because they can look at the pixel values of all the existing pixels that are filled in already and go from there, which is kind of like in movies where like police say zoom in and enhance. It's
oh my god.
Yeah. So that could happen, except obviously it's only going to be able to enhance based on the training data that it was trained on, so it's going to just use like the statistically regular thing that would happen given those pixel values. So like if you're trying to read a license plate, it's probably not going to work because that's something very specific.
Well, and that's an interesting one. So like, right, so like if for example you have a license plate that's very blurry in a photo, and you wanted, like, this like at least is a foray into the ethical issues, right? Like you want to like build some software that can like zoom in and enhance the license plate. Well, like if there's any information there, you would hope that such a software or such an algorithm would be able to like enhance the like limited amount of signal that's there and do something useful and produce like the right digits. If you ever wanted to propose using such a software, you'd have to like show that it doesn't just hallucinate the digits, right? Mm-hmm. And it's the kinds of models that we're talking about, it's constrained by reality, but like it would be doing a good job if it just, under a certain definition of good, if it just was able to like hallucinate plausible digits that looked right in the right space on the license plate.
Yeah, generative models can't produce information out of nothing. They can just make educated guesses based on whatever is available.
Or turn randomness into things that look real, which is like, I mean, that's like what they're really supposed to do, right? That's what the basic thing for a generative model is, to take total randomness and make it look real. A standard thing that a generative model can do, I mean, we'll talk about this maybe a bit more systematically, but a standard example of what you might use a generative model for would be like reconstruction from noisy or partial information. So like, let's say you had a degraded face. If you had trained this model to like encode faces into this compressed representation and then like reconstruct them, in the normal case maybe they were all like clean faces, but then like you might try to give that model a noisy face or like a partially obscured face or something like this, and see, can the model reproduce a face from the partially obscured face. And it might be able to do a fairly good job. So like, especially if things like lighting and symmetry are easy things to predict about faces, you know, you might, if you saw half a face or something like this, side like bilaterally, you would presumably be able to reconstruct the other half of the face just by kind of guessing it's like the mirror image of the side you saw. And you could do similar things like this for other kinds of features. If the person's got it's a man with a dark beard, you can assume his hair is probably a similar color to his beard. And that's kind of what we mean when we say that there's like, okay, it's capturing sufficient statistics of some data set, right? Like, there are correlations at some levels of abstraction in the data set. There are, like, if a person's got dark hair in one part of the image, they probably have dark hair in the other part of the image. And that's like a fairly high level concept, it might seem like, but it turns out even fairly simple models can sort of capture those kind of structural relationships between different parts of an image or a data distribution.
So we've been talking a lot about images. We can talk about text generation as well. And usually the way this works is, again, it's this unsupervised setting. So it's not like translation, text translation, where you have a sentence in one language and a sentence in another language, and you want to learn how to map between those because that would be considered supervised. Again, the generation of text can be done via unsupervised learning. So basically, you have just a big text. I think the Wikipedia data set is one that's used a lot. I don't think it's all of Wikipedia because that would be a lot, but some subset of Wikipedia articles can just be fed in as like an example of language. And you can train a model to say, you know, if I give you these two words surrounding a word in a sentence, can you tell me what the word in between is? So if I said the blank ran, the model might need to predict the word dog if that's what was in the sentence. And so by training models to be able to do that kind of thing, they can pick up on the statistical regularities in language, because there's a lot of those, and then be able to produce language by giving it kind of like starter words to a sentence, and then just let the model run and it'll produce word after word. So these aren't generative models in the technical sense where you're kind of explicitly trying to get at some distribution, but they can produce language that, at least the goal of them is to have the same kind of regularities as real language. So if you see something on Twitter that says like, I forced a bot to watch like 10 hours of whatever and produce a script, that's something that people put out there a lot. Like the results of training these kinds of bots, quote unquote, to watch or to read, you know, the tweets of a certain person, and then you learn the regularities and the vocabulary of that person and can produce new tweets based on that. There's also a lot of those that are just fake. There's like people pretending that they trained a bot, but they didn't. Yeah.
Yeah, I mean, I think obviously I've been surprised already when it comes to images and even audio. And so obviously maybe I should just learn not to be surprised anymore and expect the same for text. But like, I definitely feel like I'm not going to be as impressed by text generation, because I mean, it's not going to make, like, how can you possibly learn, you know, logically coherent plots just through statistical means? I don't know. I'm still skeptical about that, I'm sure. But I'm sure that's probably the majority of you anyway. I'm not sure if it is.
Yeah, I mean, I think some of the things that produce like tweets based on being trained on a big corpus of tweets can sometimes be rather compelling. Mm. It's not clear if they like make sense, but they sound like something someone might say.
Yeah. I mean, I think, like spoken sentences, like just individual sentences for sure. Like, I think I've seen some that I've been quite impressed at, but like with images, I guess, I don't know, I guess there's just not as much like logic behind an image as there is to text. Is that
Once you've built models that can produce like just the generic distribution, you can also make them like conditioned, such that you could say to like, I want an image of like a person wearing a red hat.
Yeah.
And then there's some structure to it. And
Yeah.
I don't know, like it has to know what a person is and what a red hat is.
And
be able
where
to,
the red hat goes on the person.
Yeah.
Yeah. Yeah.
And so with sentences, you could get similar thing. It's like generate from the distribution of sentences that would be like plausible for a person asking for something at a restaurant or something like this. I mean, I'm making up that specific example. But so even if the model just said, I would like some fish with garlic, like that would be, that can be impressive to me. I mean, I don't know. It's a certain kind of randomness. I mean, to me, this is all just like a certain kind of structured randomness. That's kind of interesting.
Yeah, but it is the case that, at least for now, a lot of the text generation does lack long-term dependencies. So you can get a sentence or two that feels coherent, but it's not going to be able to produce paragraphs that refer to each other later on or anything like that. And so there is a sense that, like, I mean, it's kind of ironic because some people talk about generative models as being like what's necessary to create AI or something that can understand the world, like it needs to internalize the statistics of the world. But clearly, language, while describing the world, isn't like the way that you learn about the world. Like, I think those long-term dependencies will be better produced by a model that learns about the world through other means or something like that. Like, purely reading text makes it hard to understand the causal structure of the world that would allow you to produce good text that makes sense on a long scale. Or these models just aren't complex enough. You just need to add like more layers to them, and then they'll be able to make full novels or something. I don't know.
Maybe there's some sort of like tautology that if you take a big enough model and train it on like an enormous data set of novels, it could make up novels that like maybe would fool some people, or, you know, in some limit of like arbitrarily infinite amounts of novels that you feed into the training data.
Well, this just sounds like the monkeys on a typewriter producing Shakespeare argument.
Well, no, but it's producing Shakespeare with much higher probability, right? So like, no, like the monkey, monkeys on a typewriter, random noise on a typewriter will occasionally produce something that Shakespeare wrote. Just like that's probabilistically true, even though it's extremely rare. Mm-hmm. But like the statement we're saying is if you take some enormous amount of novels, you know, like 100 trillion novels, and you train some very large model to like, you know, on the statistics of those 100 trillion novels, maybe with high probability, like 1 in 10 times, you'd produce something that would like fool people into thinking, okay, maybe a human wrote this. Like, I'm not 100% sure because there's a lot of obscure novels out there or something.
But I mean, it would be a human with like a very short attention span.
Well, I don't know. I'm saying given a complicated enough model and enough novels, it seems like it's just got to be the case that it would happen.
But now, the numbers are so big.
That's not practical. Yeah, no, I agree.
So I just looked it up, and according to Google, there have only been 130 million books at all written yet. So if you need 130 trillion novels to train this,
I was making up the numbers, and I think this is plausible. Like, my intuition is probably there are not yet enough books written to train a model that could write whole books, just from being trained on books. Yeah. If you wanted to train a model to be able to write novels, it might help to also show it all of the movies that have been written.
Yeah.
Like, not just as screenplays, but like the actual video. I think what you're hoping for in that kind of multimodality is leveraging the fact that the real world exists and that both novels and movies point to the real world.
Yeah.
So what I was trying to say with this first thing is that there is this extreme where you would hope that, like, kind of logically, in a sort of boring way, a large enough model with an essentially infinite amount of data would be able to just start generating models. That should be trivially true. That's like a statement about probabilities and models. But like more interesting is, what are the ways that you can efficiently build models, like give them realistic, like human lifetime level amounts of experience, and get them to produce novels based on like leveraging the multiple kinds of data that a human would have seen.
So we can talk about some of the questionable uses of these kinds of models. So like generating novels seems nice and fine. But there are people who have used, particularly along the lines of image generation and video generation and audio generation. I think at this point, it's a lot of people demonstrating the bad things that can be done and not a lot of bad things being done yet. So there was a video that, looked like and kind of sounded like Barack Obama saying some like crazy things, and it was automatically generated by these kinds of deep neural network models that were trained on videos of him. And so that was an example that people put out there to be like, be careful, this is coming, the technology is getting better, and this kind of stuff is going to happen. And then there's also, I think this is actually happening, or so some articles say, like deep fake pornography, where people's faces will be put on to the faces of people in porn, and so you can like claim that you have a sex tape of someone that's been artificially generated. So these are the examples of some of the bad things can happen. It's also the case that just if you can, say, train on someone's voice. So, like, for example, there are now many hours of my voice on the internet. So someone could train a model on my voice to replicate it. And then if I had something that had a voice password, then they could just make the model of my voice say whatever the password needed to say, and they would have access to whatever I stored that way. But I wouldn't use a voice-activated password or a face one. It's just crazy to me that people do that at all, even in the absence of generative models, because you wouldn't like tattoo your password on your face, so you shouldn't make your face your password. But especially given the ability of generative models, those kinds of features that seem defining and unique can be captured and used for whatever purposes people want.
Yeah, I think the tattooing the password on your face is like a striking example of this, right? It's like, it feels like, at least in extreme examples, we've kind of known for a while that like some of these things, these like these biometric identification things are like you can probably spoof them, but I guess maybe it's also the case that like in practice it's not super common for those to be spoofable, or as spoofable as. But I guess with generative models, maybe it becomes much easier, especially for things like voice verification. So like I guess a photo of your face, if people are using that as like as a login, that seems like, and I think that there are systems that do that. That seems like very clear that a person could just hold up a picture in front of your webcam. But voice verification, I guess maybe people thought previously, even if it were hypothetically spoofable using high-tech stuff, maybe with generative models, the contemporary version of generative models, maybe it's much easier than it was in the past.
Yeah, but I mean, the impact of that kind of seems relatively niche compared to like the potential impact just on like false claims and news. Basically, you can just essentially claim that some famous person said something, right? That seems like that seems potentially larger in terms of societal impact than, oh no, I have to not use voice activation anymore on my phone.
Yeah, I agree with you. I think during the election, if you had seen Hillary Clinton, and this will happen in the next election or the next in 2 elections from now or something, if you'd seen one of the candidates running for something like president say something totally outrageous or offensive, I mean, I guess if it's Donald Trump, no one would care. But if it's a person who presents themselves as having integrity, and you hear them say something totally outrageous, that could like get shared on social media, and a bunch of people will see it before the like inevitable follow-up comes along saying, "Oh, this was fake. Like this was a fake video," and people will go with that first instinct, like, "Oh, this is real. Like I see an image of something, I believe it."
And I actually just thought that people would just continue as they behave now anyway, and just either decide whether to believe it or not, depending on their biases. But
I kind of agree. If hypothetically I were on a social media site and I saw some article like, "Hey, this person said this," and that seemed kind of unlikely to me, then I would question the text, right? And like I think this goes back like at least centuries, but almost certainly far earlier in human history. People have like misreported what other people said.
Yeah.
And like you decide based on the sort of trustworthiness of the source that's giving you the information, like a messenger or a newspaper or whatever. Like you decide, do I believe that or do I not believe that? And so this is I think what you're saying.
Yeah.
And I feel like to me that the interesting catch, right, or what maybe makes things a little bit different would be like for an image, maybe there's something that like would stick with you, right? Like
Right,
we're
it's more
not
visceral.
used.
Yeah.
It's more visceral. Some sort of like weird fake sex tape of like a politician would be quite weird and humiliating to them, even if it were fake, right? It would somehow like it would evoke like a weird shame response because like we as apes are not well adapted to seeing something visual and kind of visceral and like accepting that it's fake and like discounting it appropriately.
I agree that that's a problem, but I think there still is the first problem of people believing that they're fake. I think that it'll be very easy for people to look at them and say, no, I saw it with my own eyes. Like, I saw that video, that happened. There's no way that video was fake. And so people will believe things that are fake when the quality is good enough. And alternatively, people will not believe things that are true because they'll have the cop-out of saying, no, that video was probably fake. So now you have a bunch of videos shot by people on their iPhones of police brutality or situations where they were treated poorly, and historically maybe those people wouldn't have been believed, and now that they can provide video evidence wherever they are, they get to be believed, and like the societal attitude changes. But if you can go back to being like, no, I don't believe that person, I think that iPhone video was fake and that police officer didn't hurt them, like that's a bad state to be in. And previously, like, yeah, people could report something via text and you can say like, well, I don't know if I trust that person. But then you had to step up. You could be like, oh, well, there was an audio recording, so I don't have to trust that person. And there was a video, so I don't have to trust that person. I trust what I see. There's no step up if there's fake video. I think that's the last thing aside from being somewhere in person and happening to witness the event in question.
Kind of like augmented VR that like puts you in the scene and you can look around. That might be hard to fake. I don't know.
Yeah, you'd have to then be able to fake it in real time from
Yeah.
whatever angle the person chooses to go to and everything. So that will be harder. We'll get there, but that'll be harder. But then that leads to the question of, like, can there be ways to test if these things are fake kind of via the same models that create them?
Yeah.
And so I think it's just an arms race, really. I mean, the people who are trying to make fake things, well, ironically, are often the same people who are trying to show how you can prove things are fake. But if in the future there are people who truly want to make fake things for bad purposes, they're going to try to outwit the people who are trying to detect fake things forever and ever. Because there was this one thing that there were a few different kind of like newsy articles about it, because I think it was offering people hope, because there was a study that claimed that they could detect fake videos because the stuff that the videos are trained on are usually still images of faces where the people's eyes are open, and so in the videos they don't blink, or they don't blink very much because the training data doesn't have a lot of blinking, and so they could detect fake videos easily just based on like counting blinks. But like obviously that's a very temporary flaw in these things that could be like easily fixed with more video training data that has blinking. So I don't think there's going to be an easy fix to detecting fake things because people will keep trying to outsmart them. Oh, and then the other kind of ethical element of it, which I hadn't anticipated until it happened, was Google put out this example of their assistant making a phone call. Like if you say, I want to schedule a hair appointment, the like Google Assistant that you can have on your phone can call up a hair salon and talk to a human. It's like an AI generated voice that can have a short conversation with a human based on scheduling an appointment. And they played an example of it, and it's like really creepy because they even put in kind of like ums and pauses and like, I think I'd like to make an appointment for 2 p.m. or something like that. So people were upset because they thought it was deceitful to the person on the other end, like the person at the hair salon answering the phone, talking to this AI, not knowing that they're talking to an AI. And people didn't like it for that reason, which isn't like an ethical quandary I had considered before.
Yeah. It's a bit like the Google Glass backlash, I think, where it's kind of like they want, it's there it was like they wanted to know if you're recording them, and here it's like they want to know if you're like being fake with them, I guess. But because I think that was also unanticipated. Vague.
Well, I think some people didn't anticipate it.
Yeah.
I mean, there's other similar ones, like people will use automated scheduling software where like you get sent emails like, hey, could we meet at this time? And it's like, because doing that in text is like now much easier than doing it with like video and like the appropriate sort of phraseology in a phone conversation, right?
Yeah.
Like in text, like an email, it could just literally be like, hey, when are you free in the next week?
Yeah.
And then you send it, and it figures out how to parse the times and puts something on, checks against someone's calendar and tries to book an appointment with you. What I think is at root maybe is the feeling that like you're being like objectified or used or something like this. It's like this other person who and this always happens with like power dynamics. I mean, if like you talk to someone and you get put in touch with their secretary or administrative staff or something like this, it's like, oh, well, this person's very busy and important, and so they pay another human being to like book their appointments for them. And like if you find that power balance acceptable, that's one thing. But if it's like all of your peers all of the time are using AI, it's like, at what point does it devolve into something weird and random if like you're using an AI system to book your schedule and your friend is doing it, and then like you just find times and are told what time you're meeting, and neither of you had any input on it? Like, that seems absurd.
I don't mind that if it's just AIs talking to each other to settle a schedule or something like that. The thing that I could imagine bothering me, like if I answered the phone and it was an AI talking to me and I didn't know that, the thing that would bother me was the energy I wasted in being polite. Because I'm polite and pleasant because I think it makes the other human that I'm talking to, like, have a nice day. Like, if I'm making a transactional phone call, I'm happy to put in some effort to make that pleasant. If it's an AI, I don't have to do that, and I don't want to do that. So that's the only
maybe
thing
you
that
should be polite, because then when there are overlords, like, they'll like you. So,
okay, it might be though, like the politeness might also be like, I think it is like you feel like you're a fool.
Yeah.
Yeah,
right?
it's like if you like yell at your computer or something like that. It's like, I know this is dumb, but like you don't want to talk to inanimate objects. I saw something that said, I think it was Pizza Hut or something, was testing out self-driving pizza delivery cars, and they noted that people frequently thanked the car. Like it was like a little window you could pull your pizza out of, and like after they pulled it out, they go, "Thank you," and then they walk away.
I to me it feels more like, I mean, I guess everyone's got different things. So like for Grace, maybe it's like wasting energy being pleasant is costly.
Yeah.
To me, the thing that would feel costly or like harm-inducing be like the sense that like your voice isn't really being heard or something like this.
Oh no.
No, right? Like,
Wow.
no, right? It's like you're talking to this thing and it's like, it must somehow subconsciously be related to what Grace is saying.
Yeah,
it's like
yeah,
the
yeah.
wrong kind. Like, well, if it's an AI, then why is it calling me? Why isn't it just sending me a text and I can respond with like a
That's
binary thing? Or so, like, there's also something more about like, I think we don't like the idea that we've been like had something pulled over us. So like it's embarrassing to hear, oh, that was like, it was almost like you were punked or pranked or something like this, right? Like this the system was fake.
Yeah.
You believed it was real. I don't know. Somehow it makes us feel foolish or inadequate.
I think, I think, I mean, it also might be interesting, like because it's going to have like inputs now into like how we have conversations and stuff. Like basically, like, will it change the way in which humans converse with each other? If it's going to like learn weird versions of human conversations and then do that to us, and then we'll learn that weird thing. Like, I'm not. Do you come across this? The YouTube, automatic YouTube. Basically, kitty YouTube is a big thing, and it's very, it's very good for revenue because you just show them like tons and tons of content, and they click next, and so it kind of went down this rabbit hole where you looked at some of the videos that were being put up on kitty YouTube, and I was taken down after this article, and it's just like the weirdest stuff where you have like these kind of floating cows that are all different colors, and then they inject it with different syringes, and then they turn yellow, and then they start singing this different song, and like it's stuff which seems like it's very,
fits like the statistical distribution of a child's video.
But it just it's really weird, and that stuff might like become more prevalent, when it becomes like, the reason it's popular with kitty stuff is you can do very simple animation, and they don't care about the quality of animation. When the animation gets better, they might start doing automated content for like older people, and then you're just going to get used to seeing weird shit that makes no sense.
So it'd be like a David Lynch film.
Yeah, basically.
Yeah, I mean, I guess one reason then, though, to continue to be polite to AI is so that it keeps the conversation within the realm of current human kinds of conversation.
Exactly. Yeah.
And eventually, there will be, I don't think that this is happening at all now in the Google Assistant stuff, but like emotion detection. So if you're curt with the AI, it'll be like, oh, this person's angry, I should be like slower or nicer or something like that. So like the reasons that or the information that's conveyed now to other humans will eventually be able to be incorporated and conveyed to AI as well. But we are in a weird transitional state now. So, last thing I want to talk about is just the use of generative models in neuroscience. So, there's kind of two aspects of it to that, kind of the methodology. How can neuroscience use generative models to build models of the brain or models of behavior? And then also kind of, does the brain use generative modeling? So any thoughts on any of that?
Well, I guess the use of generative models is the one that always pops to mind for me is like the Ising model or like the maximum pairwise maximum entry model, where essentially you can just use it as a form of hypothesis testing, I guess, where you basically is our pairwise correlations sufficient to describe all of the activity that we see when we record from like a bunch, maybe 100 or 200 different neurons, does that capture everything? And you can basically just fit a generative model to reproduce that, only compressing it down basically to the pairwise interactions between those neurons. And it fits it pretty well. You might need some other stuff, and but it sort of advances your understanding of what the neurons are kind of, how they're communicating essentially in that sort of constraint.
Yeah, I think that style of generative models is the style that exists currently in neuroscience, in the sense that it's not these like big deep models where you train them on neuroscience data. It's these very highly conceived, like people decided this is the way you generate this, and then you can compare it to data. So another example that I've used is generating architectures of like how neurons connect to each other. Yeah. So it could be like how many, or kind of what is the distribution of connections? Are there a lot of neurons that have very few connections and a few neurons that have a lot of connections? That's one way you could describe networks. And then there are processes for generating networks that have those kinds of properties. And then you can say, okay, if I generate a network that has, each cell has roughly the same number of connections, then what does the activity of that network look like? And does it match this area of the brain and that kind of thing? So these aren't, you're not using the data to find the sufficient statistics. You're guessing at what the sufficient statistics are and building models and seeing if they replicate the data.
So, I mean, something in both of what you're talking about these hand designed or hand specified families of models, but in both cases, it's often the parameters are estimated. So it is still the case that the data is telling you something about the structure of the distribution. So like if you have a bunch of observations of connectivity, you can fit probability distributions over graphs to those connectivity distributions. Yeah. And if you have a bunch of examples of populations of neurons, that are active with some distribution, like joint distribution, you can fit probability distributions to the activity. And so, this is statistics, right? I mean, this is good statistics. This is a largely Bayesian, but not necessarily super strictly Bayesian take on statistics, where you have, you've specified some architecture or form of parametric form of a probability distribution, and you have your data, and you fit the parameters of that distribution from your data. So in some sense, I think generative models of that form have been useful for hypothesis testing and for data interpretation and description for a while, and that's nothing new. Yeah. So what's new is being able to do it in the same way that for deep learning, deep generative models, what's been useful in machine learning has been the ability to specify basically probability distributions over much more complicated kinds of data than you could historically. So up till 10 years ago, you could fit a model that took into account kind of Gaussian-like structure in activity, or like pairwise correlations in activity. But you couldn't fit things with like complex real-world structure. You couldn't, in the same way that you couldn't historically fit distributions over natural images. So the new steps, and I think there's some excitement about this in neuroscience, and I would share in this excitement, would be like things like fitting natural behavior of animals. Things in the space of, we couldn't historically fit this because it was too complicated and rich. So like behavior would be one thing, like vocalizations or speech by animals or humans would be another thing. So just very, very complicated stuff that animals do, or stimuli that are presented to animals. So that could still be like natural images. And then using that kind of stuff in some sort of neuroscience application or analysis is I think going to be increasingly big and new.
Yeah, I think that that's maybe a future direction that I haven't seen much fruit from yet, but could happen. In terms of whether the brain uses generative models, I think that's either trivially true or questionable, depending on exactly what you mean from that. So some people would take that to mean essentially, like, does the brain do predictive coding, like predict the sensory inputs that it's going to get next, which we talked about in our predictive coding episode. And so that's the one that's a little bit more questionable. But obviously, like, the brain produces language and generates movement patterns, and, you know, like, we generate things. So
we also generate hallucinations and dreams, which are arguably, I mean, it's not trivial that a behaving organism would do that, I guess.
Sure, yeah. That's generating sensory stimuli.
Yeah, exactly. Yeah.
Based on the statistics of the world that you encounter.
Yeah.
Yeah, that's a good example of it. And presumably you're compressing the statistics of the world in your brain somehow so that you can recreate that kind of stuff.
Yeah.
All right. That's the end.
Cool.
Till next time. Hey, if you're still listening to this, you must really like us. So how about you go to iTunes or Stitcher and rate the podcast, give us some feedback. You can also go to our website, unsupervisedthinkingpodcast.blogspot.com. You can comment on different episodes, or you could give us ideas for new topics you want to hear about. We would love to hear from you. Thanks.